Kirtana, you can start now.
Yes, sir. Hello, everyone, and good morning. A small cheer and a great welcome makes a merry feast. It's my great pleasure to extend a cheerful welcome to you all. Your presence makes us very happy. I am Kirtana, the student chairperson of the IETE Student Forum, St. Joseph Institute of Technology of the Department of Electronics and Communication Engineering. I am happy to host today's webinar on opportunities and challenges in 6G wireless technologies on being presented by Dr. Sridhar Iyer. Now, I'd like to extend my first and foremost gratitude to our Honorable Chairman, Sir Dr. B. Babu Manoharan, our Managing Director, Mrs. B. Jessipriya Ma'am, our Director, Sir Mr. Sashi Sekhar, our Principal, Dr. P. Ravichandran, Sir, for giving this opportunity to conduct this webinar. I would also like to extend my gratitude to our Head of Department, Dr. C. Nyanakosalya Ma'am, Staff and Student Affairs, and Dr. G. Rohini Ma'am, Lab Affairs, for their ceaseless support. Now, I'd like to share a few words about the speaker. Mr. Dr. Sridhar Iyer received his BE degree in Electronics and Telecommunications Engineering from the Mumbai University and MS degree in Electrical and Communication Engineering from the New Mexico State University, USA, and a PhD degree from Delhi University in 2017. He received the Young Scientist Award from the Department of Science and Technology, Government of India, in the year 2013. He is also the author of an international book titled Optical Performance in the Presence of Physical Layer Impairments. He is currently the Dean R&D and the IPR Cell Coordinator at SG Balekundri Institute of Technology. He is designated reviewer to various high-impact journals such as PNET JOC, Springer, IEEE JOCN, IEEE JLT, etc. He is also on the review panel of multiple national and international funding agencies. His current research focus includes terahertz communications and spectrum enhancement techniques for 6G communication and efficient design and resource optimization of the FlexiGrid EONs enabled by SDM. He has published over 70 reviewed articles in international or national journals and conferences. Now it's time to begin the session. Before commencing the session, I'd like to convey a few instructions to the participants. Kindly post your queries in the chat box and it will be modified to the speaker at the end of the session. The feedback link will be posted at the end of the session. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. So don't miss it. Now I invite our speaker, Dr. Sridhar Iyer, to kindly begin the session. Over to
Uh,
you, sir.
Thank you for that introduction. I hope I'm audible and visible as well.
Yes, sir.
Okay. As everyone can see, the title is Opportunities and Challenges in 6G Wireless Technology. Just before I begin and go into some details, I just would want to put forth that I'm not going into the immense technical details of each part of 6G because the research is at a very nascent stage. The whole idea of the webinar is to provide to the participants the open research problems, because each of these problems are uh, research problems by themselves. So going into the depth of each and every problem is not possible in 1 or 2 or 3 hours. It takes a long time, but the whole idea is just to motivate all the participants into reading more about 6G and what are the challenges that we have. uh, I assume few of the participants would also be thinking 6G, whereas we are not even having 5G. There's only talk about 5G and little bit of deployment of 5G in our neighboring country. But why are we even talking about 6G? So through this webinar, maybe I can answer that sort of a question as well. I was thinking how to motivate the participants and the motivation. So I found this very interesting picture that really motivated me. So I thought that would do the same to all the participants. So we can see very clearly in that picture, what has happened in the past decade, 2010, what is happening now in 2020, and then what we want to want should happen in 2030. So you can see major differences in every decade. So the smartphones came in, and we had the internet, and we have so much data that we deal with every day. We actually don't call each other very much now. It is all about the data, and we have so much data that we are dumping, and all this has happened in the past decade. It was there previously, but majority of it started happening in the past decade. And now we are in 2020, and we already know the kind of gadgets and devices which are there with us. And then if you look at 2030, we are looking at applications such as holograms, looking at applications such as mixed reality. We already have augmented and virtual reality with 5G, but we're looking at things known as mixed reality. And there are many other applications which I will touch upon in the webinar. So that is the motivation of why we should be talking about a higher generation of wireless communication. And then, of course, this is something which has been there again, specifically in the past 4 to 5 years. We know that machines are better than humans. They can perform much better. Efficiency is more. But then we started talking about how to make these machines learn, so that the automation is more and human intervention is less. And now we are at a stage where we are talking about zero human intervention and 100% maximum machine learning. So there's no comparison as such between machine and humans, but just to give you an idea, I put in this table, and you can see that in terms of the important parameters, the machine is always going to exceed the human limitations, right? So that is the motivation behind machine learning, why we want the machines to learn, so that our intervention, that is human intervention, goes decreases, and one day we can possibly have zero intervention, human intervention. So just in retrospect, wireless communication, I'm sure all the participants are aware that it actually stems from Marconi's demonstration of telegraphy way back in 19th century. And then Lord Shannon took it further and theoretically constructed this information theory in 1948. So we have the Shannon's theorem, very important Shannon's theorem. That's how the wireless communication has, evolved. Taking you back in, decades behind, in 1980s, we had the 1G. It was analog in nature. We were still using the phones to talk to each other, for which actually the phone was invented. Then in 1990s, we went digital, which is known as 2G, and that replaced the 1G, obviously, because digital is better than analog. We all know that. And because of this digitization, we were able to, provide services such as messaging, you know, the encrypted services and data services. And then early, somewhere around 2000, 2002, we had the 3G. It's called as the 21st century generation. And so we had different kinds of technology which was used in 3G, like CDMA, WCDMA. We also had the WiMAX, and all this enabled various services, specifically data services. So we started having video calls and internet access, and that was more like the where we are right now. So that gave the whole idea of internet into the phones and various other devices. And then around 2009 and 2010, we had the 4G or LTE, the long-term evolution, and that is still with us. And that basically has reshaped our society. We are more accessible to internet. It uses the MIMO technology, the OFDM, Internet Protocol technology. So all of this is done in conjunction, so that we can achieve high-speed data transmission, mobile data transmission. And we have also had simultaneously the advent or and the more manufacturing of the smartphones, and now we have tablets and various other gadgets. So this has been like the trend in the wireless generations. So then now we are talking about 5G. 5G is something which is not new. Now that we are sitting here in 2021, it's not new. The first idea came back in somewhere around 2014-15. There were journal articles based on that. And then as for every generation, For 5G, the new radio and its standalone completed in 2017. Uh, the standalone versions approved by 3GPP, they were done in 2018, and now is the time that 5G is starting to get deployed. We know that China is one of the countries which has started deploying 5G, and very soon other places will also start to deploy 5G. Of course, we still have to see what would be the pros and cons once they are practically deployed. So theoretically, the work has been done. It took about 4 to 5 years for all this work to be done, the paperwork, so to say, and now it is in a position to be deployed. So we still have to see how it is, what is its effect, what would be the actual data rates that people would get, and various other latency issues and all those factors once we deploy 5G. So what are the challenging indicators for 5G? I mean, why do we need 5G? Of course, we needed 5G for very enhanced internet, that is known as the enhanced mobile broadband, very low latency, which is known as ultra reliable low latency. I'm sure participants are aware of these buzzwords, the EMBB, the URLLC. These are the catchphrases for 5G. The density, user density as well, 5G is supposed to take care of. So you could have 1 million connections per square kilometer. And then you have the massive machine type communication. This is one of the most popular ones, the MMTC, the massive machine type communication. So you have many machines, and you provide the communication to those. So compared to previous generations, 5G has will be is supposed to exceed the limits in all these factors which are stated on that slide. Uh, what are the technologies that 5G is going to use? Of course, massive MIMO is going to be one of them. Coding and modulation, of course, it's going to be advanced. So it's not just one of the techniques like a PSK or an ASK. It's going to be a mixed modulation technique. The millimeter wave frequency range is what is going to be used. You have the non-orthogonal multiplexes. The networking is going to be ultra dense, which is known as UDN. And when I talk about 6G, you will see that UDN will be included, is supposed to be included in 6G as an ultra UDN. So it will be an extension for 6G, and that is what has been proposed. Uh, and then flexible frame structure and many other factors in terms of wireless technology. In terms of network technology, the most popular one is SDN, that is software defined networking. You also have slicing, network slicing, the mobile edge computation. There's cloud computing as well. Edge computing is more in 6G, and I will touch upon that. That's one of the important aspects to be touched upon by 6G. So these are some of the technical aspects of 5G. What is the aim of 5G? Well, we are sitting here and we talk about IoT, Internet of Things. Well, the aim of 5G is basically to have Internet of everything, which basically means that it doesn't matter if you are terrestrial bound, it doesn't matter if you're airborne, it doesn't matter if you're in a forest or in a desert, on an ocean, it doesn't matter, you will get the network. So you will be connected everywhere uh, on this planet, and that is what is interconnection of everything, IoE. So currently the buzzword is IoT, but you will very soon see that the buzzword will change itself to IoE, which is Internet of Everything. So that is the aim of 5G. But as we all are aware, and people who work in wireless technology will be aware that all the communication that we talk about and what we deploy is basically just terrestrial bound. You know, so if we want Internet of Connection, Internet of Everything, then we need to look at different kinds of communication strategies, so that we can provide communication everywhere on this planet. So that is one of the aims of 5G. Whether it meets it or not, that remains to be seen. But this will be taken ahead in 6G as well. So there's problems when you are looking for Internet of Everything. These are not short term goals which can be met. This takes a long time, and these are very difficult to be implemented. So the experts have suggested that the IoE concept, Internet of Everything, could be an early idea in 5G. Means the idea would be in 5G, but there are so many issues that these actually would be resolved and then implemented probably in 6G. So that is another motivation for us to jump from 5G towards 6G. So what could be the issues? The issues could be, what about the demands? The demands are increasing exponentially. Uh, we are aware of that. Uh, what would be the industry applications? What would be the ecology of the industry? We are not aware. So these are the issues that 5G may face. We don't know. Some of these are there now. Some of it would come after the deployment or while the deployment is going on. So there are issues, and these need to be resolved. So currently, the 5G new radio is still ongoing, even though it says it is done. So this could very well be whatever I've stated. It could very well be the case of as people working in wireless would know, 1G short, 2G long. So the idea here is 1G was the one which actually stated about the communication, the SMS and those kind of things, but it actually came in 2G. 3G is the one which stated about the internet, but it actually came in 4G. So that's how 3G became short and 4G became long in terms of its aim. So you can see that it's stated that 2G was the best solution for voice communication, but voice was actually defined in 1G. And then 4G is the best solution for internet, but actually the internet was defined in 3G. So likewise, if we go by the same logic, 5G is a good solution for internet of everything, but actually it would be possibly done by 6G. So we don't know, right? So that could be one of the factors that would come into play, and this gives us motivation to move into 6G. So these are the trends that we have had in wireless communication, and you can see that the deployment was initially 15 years, then 12 years, then 8 years. So as we are progressing, the number of years it takes to jump from one generation to the other is actually decreasing. Right? So it makes sense talking about the next generation as soon as at least the paperwork, so to say, of the previous generation is completed and the deployment is started. So, going by this trend, the research on 6G by academics and industry has already started. There have been a lot of articles on that. There are a lot of meetings on that. There are dedicated projects for 6G. And actually, it is not new. It has started way back in 2016-17, and that is something I'll touch upon. So, it is definitely time for us to start our research on 6G, finish all the, as per ITU, that also I'll be touching upon. Finish everything, in terms of paper and, getting the job done on paper by 2025-26 and start the deployment somewhere around 2028-30, because our demands for bandwidth, the kind of applications that we are looking for as a human society are just enormous and technically very advanced. Therefore, the next generation needs to come up very quickly. So introduction to 6G. 6G is supposed to, it's a no-brainer. 6G is supposed to have higher capabilities compared to 5G. So what are the two main aspects in 6G that it should cover? One would be system coverage. It's going to cover, as I stated, internet of everything. So it's going to cover the entire planet wherever you are, and everything, all devices and all parts of the human society. So in terms of important parameters, so you can see this is a diagram which had appeared on one of Samsung's white papers. So in terms of peak data rate, you can see that 5G gave you somewhere around, let's say, even if we take 100 Gbps, 6G is supposed to give us about 1000 Gbps. In terms of energy efficiency, spectral efficiency, there's going to be 2 times increase. Reliability is going to increase. The latency, which is about 1 millisecond in 5G, would go down to about 0.1 millisecond in 6G. The connection density, the devices per kilometer square, as I mentioned, would also increase. So a lot of factors would increase better in 6G, or are supposed to be better in 6G when compared to 5G, and all of these would be stated in 5G, but the actual deployment probably would happen in 6G. So, but there is no clear description of what 6G is because the research is at its nascent stage. But there are many proposals of 6G, and that is exactly what I want to highlight to all the participants. What is it that has happened till now, and what is it that needs to be done so that more and more contribution can come towards 6G. But the focus will definitely be on coverage, providing very very high bandwidth, and then how to cover each and every part of the planet. That would be the crux of 6G. So as I told you before, 6G is talk about 6G, research of 6G is not something new. It has been started way back. The DARPA started its work back in 2016, and FCC had already granted the frequencies, and you can see I've highlighted the frequencies in red. It is 95 gigahertz to 3 terahertz. So we are exceeding millimeter wave. And as I will touch upon in a later slide, we are actually talking about terahertz frequency range. Okay. Someone may think we will get very high bandwidth. We are supposed to, but then there are many challenges when you're talking about terahertz. Devices which would operate at such high frequencies and many other aspects which I will touch upon. In terms of European Union, the Terrapod and Terranova started the 5G PP phase 1 started, and more projects have followed, and these projects are there online. You can subscribe to these projects and then see what are the progresses which are made. There's one university in Finland, Oulu, which is working really hard on 6G. They are dedicated on 6G, and they've had many conferences and many such uh, uh, people coming together and making a lot of efforts on 6G. Okay. Just ensuring if I'm audible and visible. Anyone?
Yes, sir, you're audible and your slide is visible.
Okay, okay. Because I just lost electricity in my room. That's why. So I think
Okay, sir.
I'm on a backup. Okay. So I'll just proceed. So what is the need for 6G? I think by now we already realized what is the need for 6G. So you can see that what is happening to the total global traffic volume, and you can see what is happening to the volume per subscription. And this is again no brainer. It's increasing exponentially, and you can see by 2030 where we would reach in both the graphs. So we are talking about traffic volume, about 5,016 EB per month. And then we are talking about traffic volume per subscription of some 257 GP per month. So these are very high values, and we need, better equipments, better technology to meet those kind of demands. I'm sure everybody is aware of the bandwidth demand because our demands keep increasing every day. So what are the issues? So if you take 2G, 3G, 4G, these are basically terrestrial communication networks. The claim is that about 70% of the worldwide population is covered, but then the reality is that due to cost and technology, only about 20% of the land is covered, and so less than 6% of the Earth's surface is covered. So we need to communicate. We need to have more coverage for communication. So 5G is also originally defined as a terrestrial communication system. So it will meet the radio limitations which are there in the uh, you know previous generations. So we need to go in for 6G to have internet of everything. So if you want to make everything interconnected, it makes sense logically. We need to start thinking that terrestrial communication will not be enough. We need to look at some sort of satellite communication working together with terrestrial communication. So we are looking at the operation between the satellites with the base stations on Earth. So we're looking at an interoperability, and once you are looking at interoperability, uh, we should also quickly realize what the problem would be because the channels are different. So a base station is a different channel, and the satellite is a different channel, and so there's going to be issues there as well. Right? but this would be one of the logical solutions to have to cover the entire surface of the earth, right? The key issue of 5G overall is internet of everything may not be possible by 5G to solve it. Therefore, will depend on 6G to solve it. Right? So till now, the buzzword, the catchphrase is Internet of Everything, and for that, 5G may not be enough. It could solve part of it, but not all of it, and therefore we need 6G. So it makes sense for us to start talking about 6G. So here I've just put in a diagram from one of the articles which I was reading, which gives you a user's perception into different communication networks, and uh, the gaps between the years from 1G to 2G to 3G to 4G and so on. You can see that these gaps are expanding, you know, and the expansion here basically is reflecting the capability of every generation. So the capability of 1G is very less, 2G is slightly more, and so on. And you can see that the capability of 6G will be more. So this is another reason why we should start talking about 6G, because 6G will be there to stay, right? So, for example, 1G faded away, 2G faded away, 3G faded away. We still have 4G, 5G, but 6G will be there for a long time because it will cater to the applications which will be there for decades. So, it makes sense for us to talk about 6G. So, I've just put in 6G. What is expected? We expect, a ubiquitous virtual existence. Ubiquitous means everything, everywhere, right? And we need a virtual existence, and you know now we do a lot of things virtually. So I hope all the participants are able to relate to that. So we need 6G very quickly. So there are many proposed architectures of 6G. So I've just taken a couple of them. So as I told you at the start, I'm not going into the details of the technical details of each and every aspect of 6G. You can see here in the proposed architecture, each of these applications, each of these technical aspects are research in themselves. So if I take e-health remote monitoring, which is there on the top right, that is research by itself. If you take drone networking, that is research by itself. If you take M2M, which is machine to machine communication, or M2H, which is machine to human communication, that itself is research in itself. And then you have VLC communication at the bottom. You have smart homes, you have AR, VR, underwater communication, you have free space optics, right? So a whole lot of networking, whole lot of communication, whole lot of artificial intelligence, machine learning will come into 6G, because as you can see in this diagram itself, human intervention is not possible, right, at all the places. And so we need to make the machine smart, and therefore AI and ML, machine learning, will play a greater role in 6G, right? So this is one of the proposed architecture of 6G. Then there is another architecture of 6G. Likewise, you have many which are available. So, but all of them will basically tell us just one thing. 6G is going to be based on AI and machine learning. AI is going to be the nucleus of 6G. We would want to make the devices, the network automated, 100% automated, to be honest, and zero human intervention. So if you look at this diagram, there are so many research aspects that one can touch upon. If you go into the algorithmic domain, then you have lots of AI related things which someone can pick on, like reinforcement learning, supervised learning. If you go into the hardware domain, then you have the upgradation, the learning, the GPU aspects, the FPGA aspects. You can go into the protocol layer. If you if you want to go into the mathematical aspects, the channel modeling, because now the channel will change. It could possibly have two channels working in tandem with each other. So there are different kinds of aspects that one can work on. So again, I'm not going into the details of each aspect of that architecture. I just want to create some motivation into what 6G would look like, and each of them is going to be a solid research by itself. So if someone wants to go into the mathematical modeling, you can see that there's encoding, modulation, and there's a channel demodulation and decoding, and it's not going to be easy because you're going to start to work in terahertz frequency range. So what is the vision of 6G? This I have already touched upon. It wants to make a ubiquitous, intelligent mobile society. Right? Ubiquitous means it will cover everything and everybody, and it will make our society an intelligent society and a mobile society. Of course, our society is already mobile. We keep moving and talking and communicating, but it will make it intelligent. And the only way to get intelligence into your system is through AI and machine learning techniques. Right? And we want to reach here somewhere around 230, because we want to meet those exponentially increasing demands by 2030. They're just going to skyrocket, the demands, right? And the bandwidth usage is again going to be very high. So we want to reach there by 2030. So this is another motivation for us to start talking about 6G and perform extensive research on 6G. So what are the requirements of 6G? The major requirements, again, I have touched upon these. This would be capacity would be one of the major issues. Another is going to be coverage, right? And with capacity, you'll have the data rate and how fast the users are going to start moving, because the density is going to be very high. So if you take a populated country like India, the density is very high, and these users are always on the move. So how are you going to provide connectivity to these users? So what would be the speed of the mobile communication, and how are you going to provide solutions to that? For internet of everything, we need very high capacity and coverage, so that would be the issue. So the spectrum needs to be enhanced. So we are going to jump from millimeter wave, which is there in 5G, to the terahertz frequency range, and the data rate is just going to again increase 10 to 100 times. So the diagram which I had shown previously through a Samsung white paper told us exactly that. So if you start at 100 Gbps, 6G is expected to reach about 1000 Gbps. So once you have the data rate and the higher spectrum, you also need the spectrum efficiency to be very higher. The latency is supposed to be very low. So these are some of the key aspects of 6G, and you can see in that diagram uh, the spectrum, which is somewhere around 110 gigahertz in 5G, will move to about 3000 gigahertz in 6G. So we're definitely talking about terahertz, and people have agreed that terahertz will be the frequency range that will be used for 6G, and I will touch upon that. Going a little bit deeper, for the ubiquitousness to be guaranteed by 6G, you need coverage which is going to be very deep coverage and very broad coverage. So here it makes sense, as I've mentioned before, to include terrestrial communication with satellite communication, for short range device to device communication, right? So these kind of newer technologies need to come up, and we then in that case then we can serve the airspace, land and sea, different kinds of places which possibly do not have enough networking as of now, right? So you can see in that diagram, 6G basically needs to be have a global and very deep coverage, and this along with capacity would be one of the major requirements in 6G, right? So there are many more requirements, so I've just listed them so that the participants can read based on their interest, because no, one may be interested in the spectrum issue, someone else may be interested in the AI issues, someone may be interested in the networking issues, and so on and so forth. So I'm just touching upon all the aspects which would be required in 6G. So we are going to have higher bandwidth, and once you have frequency, once you have high spectrum, uh, people are going to contend for that spectrum, and we need to have efficient solutions of frequency sharing, frequency reuse, and then frequency management, right? So these are all the catchphrases which have been going on in any channel that you pick in. It happens a lot in optical networking as well. How are you going to allocate the spectrum? How are you going to use the spectrum? How are you going to reuse the spectrum? And then how are you going to manage the spectrum? Here it is going to be a touch more difficult, because you are dealing with enormous amount of bandwidth, terahertz bandwidth, right? So we need to develop efficient algorithms. So this is something which I am working on. uh, so we are looking at algorithms which are there in 5G, and how they can be extended using artificial intelligence, machine learning algorithms, so that they can cater to the higher frequency of terahertz. So AI, as I told you, is going to be the nucleus of 6G. That's going to be very important. So we're going to have the envisioned scenario is that we're going to have personal mobile communication, which is going to be virtualized, virtual mobile communication. With AI technologies, we'll end up with personal intelligent networks. uh, Cyberspace security, again, that is a buzzword that is going on these days, even in 5G, and that will assume more importance in 6G, because you have enormous this data that will be there. You need to be aware of cyberspace security issues, and that will be enhanced. uh, the computation and navigation, as I've already touched upon, will be more, because you're going to now have terrestrial communication working in tandem with the satellite communication. So that will be one. These are all interrelated to the previous issues I was mentioning, like for example, massive data through IoE, which is known as big data communication, big com, collective intelligence, edge computing, cloud computing, blockchain. So these are the buzzwords that we have already heard about. Uh, Cloud computing is one that goes on in 5G, but that will most probably be converted into the edge computing. So these are some of the requirements of 6G and the applications of 6G. So if we compare 1G with 6G, or 2G with 6G, and so on and so forth, you can see that 6G, what it's supposed to have, and if it provides to us, it's going to be much better compared to any other previous generation of wireless communication. So we're looking somewhere around 2030 to have 6G starting getting deployed. So the rate is going to be very high, maximum rate, the frequency is going to be very high, and the technology which 6G will use is also going to be very high. Right? So, what would be the application of 6G? Again, this is research bound, but most of the people agree that AR and VR is one of the most important applications of 5G, and we are using them, the augmented and virtual realities. Uh, but with the computing capability, most likely, and most researchers agree, holographic communication will become one of the most important applications of 6G. There's an immense amount of research which is going on in terms of holographic communication, holograms, and so that will be one of the major applications of 6G. That's what researchers are converging to. So what would it look like? So we are looking at important services such as immersive mixed reality. Now we are not talking about AR or VR. We'll now start to talk about mixed reality, hologram, of course, digital replica. So in detail, they would look something like that. So you'll have truly immersive mixed reality. You'll have digital replicas, and these are some of the things that let's say back 1 decade back, we would have thought, okay, this will probably remain on paper, right? But today, sitting in 2021, I don't think anyone would say that this would remain only on paper. We require these kind of applications. The way our human society is progressing in terms of applications, bandwidth, need for coverage, the usage of these devices, these applications would be required by our human society. So it makes sense for us to really talk about advanced technologies, which come into play in terms of 6G communications. Right? Compared to 5G, what would 6G provide? The mobile broadband plus is already there in 5G. 6G will provide an enhanced version. The reliable low latency communication is there in 5G. 6G should provide an ultra reliable low latency. The massive machine type communication will definitely be there. Big communications will come in, the big com. Uh, Ultra reliable low latency, as I said, would now convert itself into a very secured ultra reliable low latency communication, because there's so much data and people communicating with each other. The security, privacy is going to be very important. From a 2D network architecture or communication, we will now jump into a three-dimensional communication, wherein we'll have an interaction, of the satellite with the base station. So we are not talking about terrestrial communication working in tandem with the satellite communication. So I'll touch upon that probably in the next slide or so. And then we'll have unconventional data communications, because there's going to be so much data that is going to be involved there, right? So you can see in that diagram, so much is happening, and each of that is a research in itself, right? So there's so many open problems out there in terms of 6G, so any of which it can be an interest for you, and you can just go ahead and start reading and try to get provide solutions to it. So what would be the technological trends and challenges, right? So this is again, the researchers have converged to this. So you can have six key aspects because it's 6G. So you'll have six key aspects. There'll be three new resources and three ING related technologies. So let me just state what are the ING related technologies. So the first would be expanding the coverage. So we're going to integrate the terrestrial and the satellite mobile communication. Increasing system capacity, obviously. So here you'll have a very user-centric ultra dense network, and then adding the capabilities. This is going to be very, very important. And we are to add computing and AI technologies. Please note that AI is there in 5G, but then it will be involved rigorously in 6G, and the computing will also increase, because the data that we'll handle in 6G is just going to be immense, right? So these are some of the things that are already there in 5G, and we need to do more of it in 6G. That's why they are called as the ING, coverage, increasing the capacity and adding the capabilities. What is going to be new in 6G? New modulation technique for sure, right? The existing modulation techniques will not give us the spectral efficiency which is required for 6G. So there are few proposals for new modulation techniques. One is known as OAM. I'll touch upon that. A new core network, as I stated, it will be a 3D architecture, because now you have terrestrial working with satellite, intelligent mobile community, and then you have new resource and utilization method of spectrum. So the existing ones are not going to work, right? Because you are now dealing with terahertz communication. There's also talk about VLC, visible light communication, being used mostly for indoor communication. You'll have cognitive radio and intelligent spectrum sharing. So this is something which I'm working on. How to have new resource basically would be in your spectrum in general. How to have these new spectrum allocation, spectrum sharing, spectrum reuse, spectrum management techniques, right? So the existing algorithms which are not intelligent or partially intelligent will not work. We need a complete intelligent you know uh, method for 6G technologies. So now, starting from this slide, I'm going to touch upon very quickly on the open problems which are there, and whichever is of interest to every participant, you can go deeper into it. And of course, you can always contact me. But I think I've already stated twice or thrice that I'm working on the spectrum allocation and sharing and managing issues. But there are other issues also with that anyone could work on. Right? So if you want to expand the coverage, so I've already stated that you are going to have uh, working in tandem of the satellite and the terrestrial communication. So satellite communication, this table shows us that in terms of most of the parameters, it is better. So the one thing that it is definitely better compared to terrestrial communication is if you want to have a wider coverage but at a very low cost, then you can always use satellite communication. So 6G would the proposal is to integrate your land wireless system, the base stations, with medium Earth or low Earth satellite communications, And for short communications, have device to device communications, right? So this is one of the proposals that these are some of the proposals in terms of expanding the coverage. Challenges, there are immense challenges. You need to design new core network architecture and mobility management, because now at some point you are terrestrial bound, sometime you are airborne, so all those factors need to be taken into consideration. What would be the challenges? uh, Doppler shift, Doppler variation, delay because you are transmitting and receiving the signals, and then how to contact, how to communicate inter-satellite, right? How are you going to communicate from satellite to satellite? So these are some of the issues that you can pick upon if you want to have, if you want to work on integrating the terrestrial and satellite mobile communication. Of course, the protocols are also going to be very important, because now you have different protocol for terrestrial communication, you have a different protocol for satellite. How are you going to merge them? Is it possible? If it is not, can you come up with a new protocol that works this, satellite communication with terrestrial communication? That's an open problem that needs to be solved. So you're looking at something like this, and a very novel concept of RIS, Reconfigurable Intelligence Surfaces, has emerged recently, and lots of research is happening on RIS. Uh, so it basically is an intelligent surface, right? And it will provide propagation where line of sight does not exist, and there are various other factors, advantages of using RIS, and a lot of research is going on. So I'm not going into the detail of the RIS, but it will be an aid if you want to have terrestrial communication with the satellite communication, right? And there are many other applications of the RIS as well. So if anyone is interested in the RIS, they can pick up the study on that. The next would be the resource and spectrum issues. So like I've stated before, people have converged, the researchers and the industries have converged that terahertz will be the one that will be used. There's also talk about VLC to be used for indoor communications. So you have the terahertz band somewhere between zero point 0.1 to 10 terahertz, very high bandwidth. You have visible light, which is 400 to 800 terahertz. Again, there are issues obviously, but then these would give us, the uh, the kind of bandwidth that is required for 6G. So what is 6G has basically two types. You have a solid state terahertz system, where frequency mixing would be used. Then you have a spatial direct modulation system, where it's just going to take the baseband signal and directly modulate to terahertz carrier wave, right? Easier said than done. Do we have devices which actually could do that? Do we have a modulator which will take the baseband signal and directly use the terahertz carrier wave? Remains to be seen. So but this terahertz communication can be used for a lot of communication. Could be used for health monitoring, the space communication network, and various other factors. But there are lots of issues. So I'm more interested in the issues because these are open problem. So hardware components working at terahertz is definitely an issue. Channel modeling is definitely an issue because you're dealing with high frequency. What kind of a channel would be working there? uh, Networking will be an issue. MIMO techniques will be an issue. MIMO is tough to be realized in VLC if we are using visible light, right? Spectrum access, how efficient can it be? Because now it is not static. It's not been static for long. It's dynamic spectrum access, and it's enormous spectrum. So how are you going to deal with the dynamicity of the users trying to get the spectrum, right? And then there's talk about cognitive radio, and a very new study which has emerged is what is known as a symbiotic radio. So in cognitive radio, basically you have multiple systems which share same spectrum, and utilize spectrum sensing and management techniques. In symbiotic radio, each of these multiple wireless system has subsystem, and each of them will now contend for the spectrum. So we are giving one more layer of spectrum sharing, if you want to understand it that way, in symbiotic radio. It's a very new concept, and I've seen very not much of research on this symbiotic radio. Maybe I have not seen much, but there could be. But it's a very new concept. So if anyone would be interested, they could pick up on symbiotic radio and see how spectrum sharing is done in that case. Of course, cognitive radio is something which has been there for few years. So that is also something that could be done. Definitely it will have AI related aspects based on this. And AI, because it could avoid collision, because everybody is going to contend for the spectrum. And AI could also be used for the prediction, uh, how the users are going to predict on how the users are going to access the spectrum, and many other factors, right? So like I've been saying, Samsung has already said, and many other companies and experts also believe, that to enable very high bandwidth, you're going to have the terahertz frequency. So this is something that you can work on, how to use when you're using terahertz frequency, then what are the issues and challenges, and what solutions you could provide. So that is one of the aspects. There is another new resource if you want to go this way, in terms of the antennas. You have metasurface lenses, which could be used in the the communication diagram which is shown there. You could use metamaterial antennas, right? So these are also some of the concepts which have emerged, and there's a lot of activity which is research activity which is going on in metasurface lenses and metamaterial antennas, right? So again, each of them is a research topic in itself, so I'm not going into the detail of that. But there are a lot of open research problems which are existing for metasurface lenses and metamaterial antenna. I've seen more of it on metamaterial antennas, because it does not require an antenna array, right? If I want to just make it simple to the participants, it does not require a separate antenna array, right? And it does not require the phase shifters. That's what I have read about it. Then, as I was stating, you need new modulation techniques, right? And the existing modulation techniques are not going to work. So, researchers have started, the people who work on electromagnetics specifically, they've started looking at alternatives to, electromagnetic waves, because the electromagnetic waves do not just have linear momentum, they also have angular momentum. And with that logic, the orbital angular momentum, OAM, has emerged as one of the modulation techniques, which could be used for the next generation of wireless technology. And it has some kind of a helical phase. Again, I'm not going into the detail because this is research by itself. So OAM works with many OAM modes, and each of the spacing will have large number of OAM charges, right? So here your each mode is going to be orthogonal to each other, and each of them can be multiplex, demultiplex. So you have a capacity enhancement in that terms. Of course, there are many issues such as misalignment. How are you going to actually transmit? What would be the divergence issue? So there are many issues. OAM is also known to be phase sensitive, so that is going to be one of the issues. So OAM looks something like this. So each of the modes is going to be spatially overlapped, so you're getting more capacity out of it, right? So you can achieve spatial multiplexing, very high order of spatial multiplexing, and in conventional MIMO that may not be available, right? So this is, I've just touched upon the basics of OAM. There's a lot of detail on OAM. There are a lot of research going on OAM, and so it is one of the proposed modulation techniques for 6G. Then the very important aspect of increasing system capacity. So in 5G, compared to 5G in 6G, researchers believe that the coverage range of the base station and access point is going to be very small. So we would probably like to just split the cell indefinitely, and that is known as a cell-less architecture. That is also something which is going on. But the problem is that we'll slowly start to approach the limit of the system capacity. So taking UDN, ultra dense networking, from 5G further ahead in 6G, we'll probably look at user centric ultra dense network. So it's going to be a wireless network with comparable densities of access points and density of users. So there's concept of decellular and user centric ultra dense network, and this will be suitable uh, for higher frequency band like terahertz. So there are different challenges. You'll have the network architecture challenge, management, mobility management is one of the major challenges which probably 6G will see, because the density will be so high and users are going to keep moving. Right? Interference is again going to be an issue because the users will be very close. In a populated country, definitely that's going to be one of the problems. Spectrum management, how are you going to do that? Security and privacy issues. So these are some of the genuine challenges. Excuse me. And each of these challenges, is a research problem in itself and requires lots of in-depth study. So the next, of course, makes a lot of sense. To add capability, you need AI. You need to integrate AI, and the computation is going to be very high because we are dealing with a lot of data. So uh, 6G probably would be a 3C type of network. It's going to be user centralized, content centralized, and data centralized. Right. So we're going to see large amount of data, large amount of content, and large amount of users. So 6G is going, it will have to cater to the needs of these large users having large amount of data and content. So AI is definitely going to be the nucleus for 6G, and it will enhance the capabilities and of the computation capabilities of the wireless network, the 6G wireless. So with these AI technology, you can interconnect a large number of devices. You can interconnect devices which are terrestrial bound, which are airborne. They're there over the sea, and ensure also that the quality of service is also being provided. What are the challenges? N number of challenges. Hardware constraint of AI. That's a challenge with AI. Dynamic convergence. How dynamically you can converge. Intelligence but collaborative. Intelligence terrestrial, intelligence satellite. How are you going to do that? Cloud computing, edge computing. These are all open issues in terms of AI for 6G. Right? We are also going to look at the computing aspects in 6G, and if you compare them with 4G and 5G, you can see the difference between 6G and the previous generations. So 6G basically with design convergence, so that seamlessly the end user can connect and utilize the power which is available in the network, right? And there's also going to be a concept of split computing, right? And split computing, basically the devices achieve very high performance by extending the battery life, and this is going to be one of the factors which will play a major role in 6G as well. Right? So anyone interested in the computing aspect can pick up cloud computing, which is there, and there's the concept of edge computing, which is new, and which which will be there for 6G, and it will help us in it will play its part in reducing the overall latency for the end user equipment, right? So there's a lot of technical aspects which are related to that. I'm not going into that, but edge computing by itself is a research. If you are interested in doing more on computing, the split computing will be uh, one of the aspects that you can study in depth about. Next would be the architecture, the network architecture. In the past, I think we are all aware that we had a two-dimensional architecture, but now with connecting your terrestrial with the with the satellite communication, will be having to convert it into a 3D architecture, a three-dimensional architecture. So we're going to have an integration for communication, computation, navigation. There are different kinds of applications where this three-dimensional architecture or the working together of satellite and terrestrial communication is going to help us. So the buzzword will be an integrated system, a 3D architecture. Challenges, immense challenges. One which I have stated previously already, establish once you have the 3D architecture, how is it going to work? What is going to be the protocol interoperability? Which kind of protocol will be, you know, which will be there for such an architecture to work, right? How are you going to manage the mobility? How are you going to manage the spectrum utilization in an intelligent manner? That remains to be seen, and these are challenges which require solutions. Right. So in the next slides, I've just tried to summarize whatever I have stated, and I've tried to give to the participants different points where you could look at, and either start your research work or take your research work into that direction. And because there's just immense amount of problems which are available, generally what happens is we don't get enough problems to solve, and most of the time is spent in finding the problem and then tackling it. Here the problems are immense, so where exactly is our interest? So if you look at an AI enabled wireless network, beamforming will be one of the issues. The cross layer communication between, I've been saying this, between the terrestrial and satellite communication. You'll have electric vehicles which will come in, spectrum access which will come in. So different kinds of issues would be there. If you want to view it in terms of a taxonomy, if you're looking for energy efficient communication, then energy harvesting is one of the aspects where we could you could take your research work. Wireless power charging. If you're looking at AI, then you could look at operational AI, environmental surface AI. If you're looking for privacy security, then you have quantum key distribution, you have blockchain, different other security algorithms. If you're looking for multi-band transmission, then you're looking at terahertz, VLC. There are different aspects that one could look at. If you're looking at application wise, then 6G is just going to have immense amount of applications. So you're going to have blockchain, you'll have the quantum machine learning, terahertz communication, haptic communication. This is one of the emerging communications that you could have. A cell-less architecture is again something which I have read very recently. That is something that you can work on. Edge AI is again a very new concept, and a lot of research is uh, you know to be done there. Bio Internet of Things, nano Internet of Things. There are different kinds of IoTs which would be available there. So someone can pick those and work. If you're looking at in terms of the applications, then you have adaptive learning, machine learning. You can enhance the machine learning to an adaptive machine learning. The routing schemes which would be there for the IoT systems. Intelligent services, network slicing, energy efficiency, spectral efficiency. There are just so many problems which are there, and we've heard of all these problems, but how to actually connect them to the 6G wireless communication or technology remains to be seen. So there are many such problems which are available. So this is again a taxonomy which was available in one of the recent articles, and it really explains very nicely uh, what are the key enablers, what are the networking technologies, what are the computing technologies. So you could pick your research. If you are a starter, you can pick your research in that. If you are already been doing it, then if you've already been doing your research, you will know where exactly to go ahead, right? So this could be the other taxonomy that you have, right? So what are the roadmaps and suggestions for 6G? Well, from the ITU's words, 5G standardization is already done. By the end of 2020, it's done. Industry perspective, researchers, 6G has already started. So we want to go ahead and do this till about 2024, 2026. And by 2030, start with the deployment. Actually, 2028 to 2030 is when they say that the deployment must also start. So 6G is very well there, and people are doing the research on that. And there are many open problems which are available. So in conclusion, 6G should give us very high capability. This will be one of the major applications of 6G. It is going to give us a 3D architecture and integration of terrestrial with satellite communication and short distance direct communication. It will take AI into consideration in a much larger extent and will make the society much more intelligent. So ultimately, we are looking for an intelligent mobile society, and this is planned to be done in the year 2025 and deployment around the year 2030. Okay. So these are few of the references which I've used. There are many references. There's a lot of survey which has been done on 6G. The few works which have emerged. Uh, of these, the most the one which I really liked a lot was the one by Samsung, which came out in July 2020, and of course there are many more. But the one given by Samsung really consolidates a lot of open problems of research and what has been done in terms of 6G. So that white paper is definitely worth reading. So this brings me to the end of my presentation, and I would be always open to help anybody. Those are my emails. You can contact me. Uh, uh, I'm an out and out researcher, so that's why you see all those IDs like an ORCID ID. It's unnecessary. I also have a ResearchGate profile, and of course, the Google profile will already be there. But anyone is more than free to contact me at any time, and I'm also open to collaborative work as well. So with this, I conclude whatever I had to share, and hopefully I have motivated the participants to go in and read a few things about 6G, and or at least start reading something about the wireless technology, because we are using it on an everyday basis. So I hope I was able to motivate the participants. So I'll be open to any questions if any participant has. Thank you.
Yes, sir. Thank you so much for sparing your valuable time amidst your busy schedule, sir. So now shall we move on to the Q&A session, sir?
Yeah, yeah, sure. So I'll quickly unshare my screen if that is okay.
Sir, am I audible now?
Yeah, you're audible.
Sorry, sir, I had a network issue and
Yeah, yeah, yeah. I was just saying that I have unshared my screen. I hope.
so your slide is not visible, sir.
Yeah. Do you want me to share the slide or?
No, sir, no, sir.
Okay. Thank you.
Okay, sir.
Yes, Keetana? Keetana?
Kitna?
Whether she is in online?
She,
Keetana?
yeah, it looks like she is connected, but
Whether she is having any network problem. If there is any network problem, others can proceed with the thing. I think Mira is here and or other IAT member. You please send from the participants and then you post it. Hello, Emmanuel.
Madam, yes, madam. We are just having the questions being posted.
Okay. And thank you, sir. I hope that students they got more information, and also the faculties they got the research challenges in the 6G technology. And many are doing there, and they are doing, and they are going to do PhDs. I hope that this will be a useful session for them to get the problem statement. And I also want to share with you some of the information about our students. And that is our second year student. He got an award in the month that is the ecliptic month that was conducted the month of December 2020. I think Kamalesh, you are here. Kamalesh, and he got some idea and he want to share his idea with you and to get some of the feedback from you. And the same way, one of our third year student, Mr. Dhanush, he is also working and he is more interested in the research field, and he has developed many apps, and he got award from the Anna University project competition, and many more things.
Yeah.
And I also want to have some interaction with this people. If you find some time to share that is your views about their project, and I think Dhanush and Kamalesh are here. Emmanuel.
Madam, looks like Dhanush is here, madam.
Yes, you can ask Dhanush to have some interaction with us.
Fine, madam. Definitely.
I think meantime they'll get the questions from the participants, and you can post it.
Yes, madam. Kirtana, are you connected?
Yes, sir, I'm connected, sir.
Yes, you
Yeah,
got
you can post the questions.
Yes, you are having all the questions with you.
Yes, ma'am,
Have
I'm
you
having,
selected?
ma'am.
Yes, sir. Then we can have the question per session. Afterwards, I think we can have some interaction with our IETE members if you find comfortable with the thing, and if you find time, please. We need your guidance also for the students to proceed further.
Sure, ma'am. Sure. Not a
Thank
problem. Not a problem.
Thank you, sir. Now we can have the query question session. Kirtana, please proceed.
Yes, ma'am, thank you, ma'am. So, sir, the first question is in machine learning, which algorithm is adopted for security enhancement while implementing 6G?
That is, you'll probably hear this answer for most of the questions, because 6G is in such a nascent area. I mean, in such a nascent stage, there is not a fixed algorithm or a fixed, what should I say, a technology. These are all proposals. So still, all of this is being researched. So I think the participant or the participants should understand that we are looking for the solutions. And if you actually look at AI and machine learning, it is such a vast topic. There's not one algorithm or two algorithms which are good, best, or efficient. It's not like that. It really depends on your application, right? What you are trying to do and why you are using machine learning. So I know that I will not give a specific answer to that. Maybe the participant is not who has asked this question may not be happy with the answer, but there's no such fixed machine learning algorithm dedicated for 6G yet. It could happen. You could find few algorithms which could be used for 6G, but still the research is in nascent stage. We are just fixing the aspects such as machine learning will be used, AI will be used, terahertz will be used. So it is at that stage. Implementation wise is where the research is headed, and all of us are more than welcome to offer our solutions to that. So that would be my answer to that question.
Okay, sir. Thank you, sir. So the
Welcome.
next question is, how 6G technology will be beneficial and when it will be launched in India?
In India, well, we are still waiting for 5G. Our Honorable IT Minister Ravi Shankar ji, I think last month, if I'm not mistaken, mentioned that India is moving towards 5G. So we will have 5G definitely. My guess is this year, because of the user density and our bandwidth demands and applications which we are doing, specifically post COVID scenario. We need 5G in India. So we'll probably see 5G. 6G, I don't know. ITU says by 2030, but then again, going by the manner in which the generations have gone, in India we usually have about a delay, so to say, of about 3 to 5 years. But the same could not happen. I don't know, and I really don't want to touch upon any government-based issues because I'm not into that. But we will see 6G in India because we are. The topmost telecom users. We have so many users and a lot of funds which are generated, so it will come there. So this was just the answer to the second part. The first part is how it will be beneficial. Well, zero human intervention and complete automation of network and systems is something that we all are looking for. Whether it is good or bad, that is another issue. But we all are looking for that. And in our day-to-day life as well, we want to be as automated as possible. So that would be 6G. The other would be the coverage. So if I want to put it in a layman's term, we don't have to run from the basement to the terrace to look for network. That would not happen in 6G. 6G will give you network wherever you are. So that these would be the advantages of 6G. Right. Thank you.
Okay, sir. The next question is, in 6G, how many number of antennas would be considered for deployment compared to 5G?
Massive MIMO is what is going to be used. But then again, we are also looking to use metamaterial antennas, which actually do not require arrays of antennas. So which one to use? Again, as I said, answering the first question, this is something that you would hear in most as an answer to most of the questions. It is the research is at a nascent stage, so we don't know what is going to be used. There is talk of massive MIMO, obviously, but then if you're using VLC, MIMO is known to be not that efficient. Therefore, it is used only for indoor communication. So we don't know. If you're going in for metamaterial, metasurface antennas, they don't require arrays. So we don't know what is going to be used. There's research going on. So let us wait and see which is going to be used. But from what I gather after reading, MIMO will play a part. So we would be looking at arrays of antennas. How many, that remains to be seen. Of course, here I also want to highlight what will come in the articles and white papers will be on paper. The actual number and actual implementation is known only after deployment. That too after a run of about 6 months to 1 year, and you actually come to know how it is actually working. So there's a long way to go to actually answer that question. Thank you.
Okay, sir. So the next question is, with higher operating frequencies, there will be issues related to coverage range. Will this lead to more number of small cells?
That's what. I had actually touched upon this in one of the slides. Small cells, yes. Actually, there is a talk of cell-less architecture, but that would in turn affect it would reach the limits of the system capacity. So we really don't want to do that. Of course, there's trade-off. So you go higher in frequency, what would be the coverage? So therefore, we are talking about the integration of terrestrial with satellite communication. Because this is one of the issues, so that would be a solution. But then it generates its own problem. What would be the interoperability between the satellite and the terrestrial communication? So these are all problems which come with one or the other solutions which are provided. So yeah, the question is right. There will be issues, but then this is what requires the solution if we want an intelligent society. Okay, thank you.
Yes, sir. Thank you so much, sir. So that's all from the questions from the participants, sir.
Yeah.
Uh,
Uh, Please wait a minute, Kirtana. Danush?
yes, sir.
Yes, sir.
Yeah, yeah. You just interact with the speaker.
Okay, sir. Hello, sir.
Tanush, you introduce yourself and then you proceed with the question.
Okay. Hello, sir. I am Dhanush from third year.
Hello.
Yes, sir. As you said, video traffic will be less on 6G, and the main scope of 6G will be on hologramic projects. I am deeply interested in holograms, sir, and I am currently working on AR-based Android application. Could you please share your views on hologram projects, and how could I develop my skill on hologram?
Yeah, that's a, so. Like I said, my first answer, you will hear a lot of this. The researchers have said that hologram will be one of the major applications of 6G, where there are some certain white papers and reports which claim that digital replica would be one of the you know uh, major applications, and then there are some which claim that mixed reality would be one. So as such, if you really want to go in with applications for 6G like hologram as you say, then as I had mentioned during my speech, there's a University of Oulu in Finland which has actually started the research on 6G, and they have published many articles based on this. So they have, I think if I'm not mistaken, about 3 articles which talk about the applications of 6G and the progress in terms of hologram, mixed reality and digital replica. What is the progress? So it's still not out there in the market obviously, but then what is the progress that has been made yearly? They have provided in their white paper. To be very honest with you, I do not work on the application of 6G. I work mostly on the spectrum issues, but this is something this university and their flagship, as they call it, will be helpful in answering your specific questions. So I'll be more than happy to share the link of that flagship and the material that they have. It's out there in the open for the public, and you can pick and choose the one that really is of interest to you. But to answer your question, as far as I have gathered, it is still in the research area. There's not much that has been done in terms of hologram. I think it will now, it is just in the starting mode, but there are many issues which are there, and those will be highlighted in those white papers. So I'll share the link with the coordinators, and they can pass it on to you. I hope I
Okay,
was
sir.
able
Thank you.
to answer some question. I know I cannot answer specific doubts because it's still under a lot of research. It's just on a survey that many people are doing. Even channel modeling, if you pick, there are only proposals of the channel modeling. There's nothing fixed here. So a lot of research is going on. So, but this is the status. I'll share the link, and you can access it.
Okay, sir. Sir, and many of them are saying that hologram is a failure project, sir. And
Yeah, I mean, when you don't get solutions, it looks like a failure project. So, but there are people who are working on it. So, as a researcher, I wouldn't consider it to be a failure. As a researcher, I would say that it may not be used, but then it will come back again. It's the same with AI and ML. AI and ML is not something which is new. It's been there since 1950s. We just didn't use it for specific purpose. But then now that we need intelligence, it has just come about. So you could consider it to be a failure in the way people perceive it. But there's a lot of research going on. So again, it's my opinion, I wouldn't consider it to be a failure. Maybe solutions are not available, or maybe they think there are no applications for it, but then it will definitely come up. Maybe bandwidth could be one issue. It requires a lot of bandwidth, but with terahertz, I think we should be able to cater to the needs. So I don't know if failure should be the term to be used, but again, you'll have to look into the details of what's going on
okay, sir. Thank you. Thank you so much.
there. Well,
Sir, now we have Miss Mira to. She wants to interact with you, sir.
sure.
Good afternoon, sir. This is Meera from final year of St. Joseph's Institute of Technology. Sir, first of all, I really liked your session,
Thank you.
and my area of interest is towards the wireless sensor networks. And so, like, I have few questions because recently I started doing few research on that particular area, and we know that we have a lot of topologies involved in wireless sensor networks. And from your point of view, let's say that there is an application of monitoring basis in an environment where we have to cover a particular space of area. In your point of view, what do you think, which topology would be more energy efficient? Because I am battling towards two topologies, one being the mesh topology and one being the grid topology, which happens to be one of the great research areas of this decade. So from your point of view, which would be a more energy efficient at the same time and very fast computing from your point of view? So is it going to be mesh, or is it going to be smart, is it going to be grid topology?
So you've put me in a spot of bother because because you need energy efficiency and
Yeah.
you also need fast computing.
Yes, sir.
Uh, they're north and south. So,
Or
yeah.
it's just the energy efficiency, so just on that basis, since wireless networks is based on that. So
Okay, so now I'm feeling a little better. I think.
okay.
so again, you need to understand here. I'm not an operator. I'm
Yes,
not a
sir.
telecom operator. So I don't know what it's out there in the field. Okay. So from what I gather through research, reading research, and also interacting with the telecom operator, it's generally the mesh which
Right.
is used.
Yeah.
But of course, there are countries where the grid is also used.
Yes, sir.
And in terms of energy efficiency, it really depends what you consider as efficient. You know, there are many people who think that if you switch off the AC, that is energy efficient.
Right.
If you switch off the fan and light, so that's energy. So it depends on your perspective. But in terms of networks in general, it doesn't matter if it is only wireless or optical. The lesser you use the nodes, because the
Yes, sir.
nodes are self-capable these days.
Yeah.
Like you have a transceiver,
Yes, sir.
transmitter, receiver. So once you use these nodes as less as possible, that's how you're trying to save the energy, because you're not sending the data through them. Every time you switch them on,
Right.
you need to pull them. There's a capital expenditure which you have already spent to buy them. There's operational expenditure, paying the power bill and so many other things. So it's not just so easy to just be energy efficient. In terms of answering your question, I would go with mesh, but then again, I would leave it a little open-ended, saying that it depends on where you're at. But if you're doing some kind of simulation,
Yes, sir.
on a computer using any kind of software like NS2, Qualnet, MATLAB, then I would say you can go in for a mesh architecture.
Right.
That is the one which is generally used.
Right. And so I have a final question to be as a follow up.
Yeah,
We have different types of routing protocols. We
yeah.
have routing algorithms. And I know for a fact that a lot of research is going under the routing algorithm, which is very efficient in routing the data to the base station. So, do we have any particular algorithm that proves efficient in monitoring such big spaces? Sir? Like when it comes to protocols, do we have any specific protocols that prove to have a good energy efficiency, or timings have been very fast to compute? So like, let's not talk about energy efficient here, at least the fast computing, has it proved any efficient here?
No, because the answer is no, because you're dealing with one different topology,
Right.
because your topology may not be the same topology as mine,
Okay.
even though it
Okay.
is mesh. So you
Yeah.
could use a 20 node mesh topology. I could be using a 10 node mesh topology.
Right.
The simulation is different.
Yes,
The
sir.
number of nodes are less. The capability into my 10 nodes could be higher than the capability of your 10 nodes, your
Right.
20 nodes. So
Right.
there are different factors. Therefore, you cannot have a shortest path algorithm, as we say,
Yes,
Dijkstra's
sir.
algorithm,
Yeah.
like that algorithm. But to be energy, that's what I think I was trying to say. If you're looking for energy efficiency in terms of any network, you try to use minimize the use of nodes as much as possible. So I want to keep only those nodes alive or on which have been used a lot, because they've been on for a long time and I don't have to pay anything extra to keep them on. The ones which are sleeping for a long time, I just don't disturb them at all. So that's how I increase the energy efficiency. So when it comes to routing, I would logically want to route my data through that kind of path, which will only make the nodes which have been alive for a long time alive again. So I wouldn't necessarily go with the shortest path, because it could be shortest path, but it will get those nodes to start working which have been
Yes, sir.
sleeping for a long time, and that will increase my cost.
Yes,
So
sir.
there is a lot of other aspects which are also involved in what you're trying to say here. So
So,
yeah.
yeah. So
So
is it like on a basis of your needs, sir? Can we put
yeah,
it like
definitely,
that?
definitely. Yeah, definitely. It depends on your application. It depends on
Right.
your application. Yeah.
Okay.
With WSNs, it depends completely on your application. So
Yes, sir.
there's a trade-off. So
Yeah.
again, I will go back to Simon Akin's first page in
Yes, sir.
communication. You have a trade-off between power and bandwidth,
Yes, sir.
right? And
Okay.
these are the two aspects which any communication needs to satisfy. So
Sure.
but there will be trade-off. So whatever you decrease, something else will increase, and so on and so forth. So you really are looking at your application.
And so just final question, like, do we have any security involved? Let's say that when I have to, say that my mode of communication protocol is going to be Wi-Fi between the sensor nodes, let's say a cluster and a particular base station or the sync node. So will there be, let's say that there are going to be few security issues that are going to be involved. What kind of algorithm? Because I recently read in a research paper that Hamming codes generally are used here, Hamming residue algorithm, a particular algorithm which I came across, which does not use key implementation. So do you think that even now key implementation will be better, or we should go into something which is more into research based algorithms, or are there any algorithms that are coming up which are going to be very, which are very effective? From your point of view, have you tried any encryption algorithms which have proved to be
Uh,
very good?
Yeah, actually, to be honest with you, till about last year or so, I was deeply involved into research on optical networks,
Right.
and then gradually I shifted into wireless network because of 6G,
Okay.
and my focus has been only on spectrum. So I'm more
Okay.
of a
Okay.
spectrum fellow,
Right.
but I have been reading a few on the security aspects, security and
Right.
privacy. So from what I gather, key will be used,
Yes, sir.
but now it will turn into quantum key. So
Okay.
you probably would want to look at QKD, the quantum
Okay.
key distribution,
Okay.
and again it will involve the key. The key will not go, in my opinion,
Okay.
but more of quantum is you're dealing with light,
Right.
because and that will give you more security than
Sure.
your previous keys, because you'll have to go so many levels of encryption and decryption and those things. But with quantum, that's not necessary.
Right.
So
Okay.
probably you want to go in and look into quantum key distribution.
Quantum key
There's
distribution.
a lot of research going on there,
Right.
and I think that would answer your question.
Okay. Thank you so much, sir. It was a pleasure
Yeah,
talking to you. Thank you.
welcome. Same here. Thank you.
Thank you, sir. Sir, shall we conclude the session, sir?
Yeah, it's up to you. If there are no other questions, I'm actually very happy that the students have interacted, and that shows that research is active at your institute, because research is the way to go about it. Because with the access to so much teaching material out there, this is again my opinion. The challenge to all our teaching fraternity is to motivate the students towards research. We cannot just keep doing the blackboard scenario anymore. I think most of the teachers here would accept what I'm saying, and we need to do a lot of research on state of the art, not the older kind of problems. And I'm very 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 happy and very glad that many of the students have come up and they've asked me these questions. And some of the questions are it shows that the students are well read. So it's not some of the questions which show that someone has fed them with questions. These are genuine questions, and uh, well read students are very good for an institute. So I congratulate your institute for that. And I wish all the best to all the students who have asked me the question, not asked me the question. I hope I've motivated the students. And I would like to thank the management, the HOD, and everybody. Bino sir specifically, because he took up the the messagings with me, and fixing up the time and the poster. So thank you very much for having me, and I hope I was able to live up to the standards of what you would expect in a webinar. So thank you.
Thank you, sir. Thank you very much for sharing your information with our students, and I hope that students are also benefited with your information, and they got some idea, and also our faculties. Thank you very much for sharing your valuable time with us.
Thank
And
you.
I request Keetana proceed with your thing. Keetana?
Yes, ma'am. Yes, ma'am. I deem it a great honor to propose the gratitude on this wonderful occasion. First of all, I'd like to express my heartiest thanks to today's speaker, Dr. Sridhar Iyer, and our chairman, Dr. B. Baba Manoharan sir, our managing director, Mrs. V. Jessipriya ma'am, our director, sir, Mr. Sashi Sekhar, our beloved principal, Dr. P. Ravichandran sir, for their generous and ceaseless support in organizing this event. I also thank our head of department, Dr. C. Nyana Kausalya ma'am, staff and student affairs, Dr. G. Rohini ma'am, lab affairs, for their words of encouragement and guidance. Also, I take this opportunity to thank the entire fraternity of St. Joseph's Institute of Technology, St. Joseph's Group of Institutions, for making this event a memorable success. Last but never the least, I thank the entire active participants for your support. I conclude this session by saying a quote: never stop learning because life never stops teaching. So keep learning and be passionate. Stay home, stay safe. Thank you all.
Thank you.
Thank you, sir.